and welcome to our physics lesson today. My name is David Muvita. Last time we were looking at light, and we said that light travels in a straight line, and then that is part of light, the straight lines are called rays. And then we also saw that because light travels in a straight line, when it is obstructed by an object, a shadow is formed behind the object. And then we also saw that because of the formation of shadows, that's how we have what we call the eclipse of the sun and eclipse of the moon. Now today we want to see what happens to light that bounces off the object. If light strikes an object, it bounces off. Sometimes it is absorbed. But today we are interested in the bouncing of light. At the end of our lesson today, we should be able to understand what the bouncing of light is called. Then we are also going to be able to distinguish between what we call an incident ray and a reflected ray. Then we are also going to know about the laws of deflection. Then we should be able to distinguish between the types of deflection. Then we should be able to draw diagrams to show how images in plane mirrors are formed. So now, let's get into the details of our lesson today. To begin with, let's do a simple experiment. What I have with me here is a mirror. Now, let's see what happens to this mirror if I tilt it at an angle such that the light from the source of light is reflected towards you. Now let's see what happens if I produce a single ray using the ray box. So you can see the ray of light coming from the ray box, striking on the mirror, and it bounces like that. The white piece of paper here is just there to show the ray clearly. This is what happened when the ray of light struck the mirror. So this was the ray that was produced from the ray box, and then it bounced off the mirror into that direction. This ray that approaches the mirror is known as the incident ray. And when it bounces, the ray that bounces off the mirror, or the path taken by light after bouncing off a mirror, is the reflected ray. And then just at the point where the incident ray strikes the mirror, or any other surface where the ray will be reflected, that point is called the point of incidence. Now, at the point of incidence, there is an imaginary line, this line here, which is perpendicular to that point here. This line is known as the normal. The angle between the normal and the incident ray is known as the angle of incidence. Then we have another angle R, which is between the normal and the reflected ray. This angle is known as the angle of reflection. Now let's look at the laws that govern deflection. There are two laws that govern deflection. The first one states that the incident ray, the normal and the reflected ray, all lie on the same plane. That means they can be drawn, for example, on a plain piece of paper. Or let's have a look at these three markers that I have with me. Imagine this is the incident ray, and then this green one is our normal, and the red one is our reflected ray. That means they can be in this same order like that, and not whereby the other one is like that, the other one going that direction, where it is not flat or plain like that. So that is what happens to the incident ray, the normal and the reflected ray. The second law says that the angle of incidence is always equal to the angle of deflection. That means angle I is always equal to angle R at the point of incidence. Now, what happened when we got the mirror and made it deflect right from the source? You would saw a bright light towards you. Would that happen if I get this plain piece of paper and tilt it like I tilted the mirror? No, that would not happen. Why? the mirror is plain, it is smooth, but the paper is a little bit rough. All objects can reflect light, but sometimes they might absorb part of the light. Now, why do others look shiny when they reflect light and others they do not look shiny? There are two types of reflection. So let's look at the types of reflection here. One type of reflection is known as regular reflection. Regular reflection. Now, what type of reflection is this? This is the kind of reflection that took place when we tilted the mirror towards the source of light so that it could bounce into your eyes. This type of reflection takes place on a smooth surface. When this happens, most of the rays that bounces off the smooth surface will go in one direction. So we have a smooth surface like that, and we represent our reflecting surfaces in that way. So let's imagine these are the rays coming towards the surface, the incident rays or the incident beam. When it strikes this surface, it will bounce in that direction. So most of these rays will bounce in one direction, such that if your eye was here, you would see most of this light coming from this end. Now, let's look at the other type of reflection. So, let's look at the second type of reflection. The second type of reflection is called irregular or diffuse reflection. Now, it is just opposite of the first one, regular reflection. This one takes place on a rough surface, such that when the rays strike the surface, they scatter. They do not go in one direction. That's why when light strikes a rough surface, a rough object, this object would not appear to be shiny. Now let's look at what happens with diffuse reflection. Now imagine this is a beam of rays coming towards the rough surface. When the rays strike these surfaces, let's take for example this ray here. If this ray strikes here, it bounces in that direction. The other ray here, if we make a tangent here, this ray would bounce in the other direction like that. This one, if the tangent is here where the 90 degrees angle is supposed to be to make the normal, then we would say this one would go in that direction. So we can see that these parallel rays tend to scatter, unlike in the regular reflection, where the parallel rays actually are reflected parallel again. So these are the types of reflection, and that's why we see certain objects to look shiny and others not to look shiny. Okay. Now, when you look at objects that look shiny, objects that bring about regular reflection, usually you would see images that are in front of that object. Let's take for example, when you look into a mirror, you see yourself or you see things surrounding you, including yourself, of course. Now, what really happens to produce those images? So let's see what happens to the rays of light that brings about those images you see in the mirror. Alright, now let's look at how the rays from the object will move so that you see the image of that object into the mirror. Now we have this object here, and then there are a number of rays striking the object, and we have just picked two rays in this case. Now these two rays, one of them is this one here. It strikes the mirror. Of course there is a normal there. It strikes the mirror and bounces in that direction. The other ray, this one also does the same, strikes the mirror and bounces into that direction. Now, when these rays fall into your eyes, your mind will interpret that light, because light travels in a straight line, these rays are coming from somewhere inside the mirror there. and then you'll be able to see the image of this object inside the mirror there. But if I hold my mirror like that, I see myself in the mirror, or I see this spark I'm holding in the mirror, and I check behind, I will not see the image that I'm seeing in the mirror. Why? Because these rays, in this case, these rays are not going beyond the mirror. It is just the mind that is making up that image that I'm seeing in the mirror. This image is not a true image. It's not a real image because light is not actually coming from that point. We call these images virtual images. So this is a virtual image. It is the opposite of what we call a real image. A real image will be formed if light was actually passing through the point where the image is seen. So this is what happens when we see objects in a shiny surface. So the rays will bounce into our eyes, and then our mind will interpret that they are seeing there's something behind or inside that reflecting surface. Now let's look at the characteristics or properties of images that are formed by plane mirrors. When I say a plane mirror, I mean a flat mirror. Other mirrors are curved. But we are interested for today in images formed by a plane mirror. So if we get back to our previous diagram here, we saw that the image formed here is not a real image because light does not actually reach there. So one of the characteristics of images formed in a plane mirror is that the images are virtual. Two, when you look into a plane mirror, if you have a small face, the face will appear small in the mirror. If you have a big face, it will appear big. If I hold this pen towards a mirror, it will appear the same way it is, same size. We say that the images formed in plane mirrors are the same size as the object. So the size of this object that we had here should be the same size as that. Maybe sometimes you have looked into a side mirror of a vehicle. The objects in the side mirror of a vehicle have appeared usually small because that mirror is not a plane mirror. Sometimes you've gone to certain places where you have found mirrors that will form your head to appear a little bit round or maybe oval shaped. Those are not plane mirror. A plane mirror will produce an image exactly that of the object. So that is another characteristic of images formed in a plane mirror. They are of the same size as the object. 3. If you stand in front of a big mirror and you raise your right hand, the image or your image in the mirror will seem to have raised the left hand. Let's look at what happens when I write this letter E, for example. And then let's see what happens to the image of this letter in the mirror. It appears as if this letter has been written like that. So images in a plane mirror are inverted. We say they are literally inverted. That is one characteristic of images formed in a plane mirror. So the third characteristic of an image formed in a plane mirror is that it is literally inverted, like we saw with the letter E that we wrote. Or when you raise your right hand or left hand, it will appear to be the opposite with the image. The fourth characteristic of the image formed in a plane mirror is that the image is as far behind the mirror as the object is in front of the mirror. So if the object is, for example, 2 meters in front of the mirror, the image of that object will be seen to be 2 meters behind the mirror. Let's look at our diagram again here. So if this distance from there to the mirror is let's say 4 meters. Even the image behind the mirror should be 4 meters behind the mirror. So we say that the images are the same distance behind the mirror as the object is in front of the mirror. Same distance the mirror. So those are the 4 characteristics of images that are formed in a plane mirror. Now, before we end our lesson, let's try some of the questions that we have with me here. The first one says, define the following terms. Incident ray. B, normal ray. C, reflected ray. And then question number 2. State the 2 laws of reflection. Question number 3. What type of reflection takes place on a rough surface? Question number 4 says that complete the ray diagram below to show how the image of the candle flame will be formed. So this is our diagram. Right, now let's go through the questions together and see what you got. Define the following terms. A, incident ray. What did we say an incident ray is? Say, this is a ray that approaches the reflecting surface. The ray that approaches the reflecting surface. B, a normal. What is a normal? A normal is not a ray in this case. It is just an imaginary line that is drawn perpendicular at a point of incidence, perpendicular to the surface. So the ray that is drawn perpendicular to the surface at the point of incidence is what we call the normal. The reflected ray. This is the ray that bounces off the reflecting surface. Or we can simply say it is the path taken by light after reflection. The ray that bounces off the reflecting surface, or the path taken by light after reflection. Question 2. State the 2 laws of reflection. We said the first law states that the incident ray, the normal, and the reflected ray all lie in the same plane. And the second law said that the angle of incidence is always equal to the angle of reflection. Question number 3. What type of reflection takes place on a rough surface? What type of reflection takes place on a rough surface? We called this diffuse reflection or irregular reflection, which is the opposite of regular reflection, which takes place on a smooth surface. So our answer for question 3 is irregular or diffuse reflection. Question number 4. Complete the ray diagram to show how the flame of the candle will be, the image of the flame will be seen in your eyes. Complete the diagram to show how the image of the candle flame will be formed or will be seen in your eyes. So you get your rule. So we extend these rays beyond the mirror. But remember, these are not actual rays. So we don't use straight lines, but we use dotted lines. Dotted lines to show that light is not actually passing through that path. This is where the image of the candle will be formed or will be seen by your eye. So you would have completed the diagram. Remember, this distance here should be equal to that distance there. So to end our lesson today, let's go through what you should have learned today. In our lesson, you should have learned to distinguish between the incident ray, the normal, and the reflected ray. You should also be able to state the laws of reflection. Then you should be able to distinguish between regular and irregular reflection. You should be able to draw ray diagrams to show how images in plane mirrors are formed. Then you should be able to list the characteristics of images formed in a plane mirror. From me, David Murita, it's goodbye.